What's up? I'm Jacko. Today we're building RAG systems, Retrieval-Augmented Generation. This is how you give your AI a knowledge base. Instead of the model making stuff up, it searches your documents and answers with real data. Practice everything on dataforall.dev, link in the description. Let's go. Here's the roadmap. 8 sections that build a complete RAG system. First, vector databases, how to store and search embeddings. Second, chunking strategies, how to split your documents. Third, embedding pipelines, converting text to vectors. Fourth, retrieval patterns, semantic search, keyword search, and hybrid. Fifth, query rewriting, making queries smarter. Sixth, reranking, refining your results. Seventh, evaluation, measuring if your RAG actually works. And eighth, the full pipeline, end-to-end. Vector databases are built for one thing, storing embeddings and searching them fast. An embedding is a list of numbers that captures the meaning of text. Similar texts have similar vectors. These databases use special indexes. HNSW and IVF are the main ones. HNSW builds a graph for fast approximate search. IVF clusters vectors into groups. You search with cosine similarity, Euclidean distance, or dot product. The result is the top K most similar documents. Two popular options. FICE is Facebook's vector search library. It handles billion-scale datasets. It's GPU accelerated, it supports IVF and HNSW indexes, but it has no built-in persistence. You manage storage yourself. Best for large-scale production. ChromaDB is the opposite. Simple Python API, built-in persistence, metadata filtering out of the box. Auto-embedding support. Best for prototyping and small to mid-scale projects. Start with ChromaDB. Move to FACE when you need scale. How you split documents determines retrieval quality. Fixed size chunking splits by token count. Simple, but it can break sentences in half. Good as a baseline. Recursive splitting is smarter. It splits by paragraphs first, then sentences, then words. This preserves semantic boundaries. Overlap is critical. Use 10 to 20% overlap between chunks. This prevents losing context at the edges. And always attach metadata. Source file, page number, section headers. You need this for citations later. Finding the right chunk size matters. 256 tokens gives you fine-grained results. High recall, but noisy. 512 tokens is the sweet spot for most use cases. Good balance of context and precision. 1024 tokens gives you more context per chunk, but lower granularity. The pro tip, experiment with chunk sizes on your actual data. Use semantic chunking for complex documents, and always preserve document hierarchy as metadata. The embedding pipeline converts your raw text into vectors. 4 steps. Pre-process your text, generate embeddings, store them in your vector database. Batch processing is essential. Process documents in batches to maximize throughput and reduce API costs. Caching saves money. Cache your embeddings so you don't recompute them. Invalidate when source documents change. For model selection, consider OpenAI, ADA 002, Cohere Embed, BGE, or E5. Choose based on benchmarks, your language, and cost. 3 main patterns. Semantic search embeds the query and finds the nearest vectors. It captures meaning, not just keywords. This is the core of most RAG systems. Sparse retrieval uses BM25. Classic keyword matching with TF-IDF scoring. It's great for exact term matches and rare words. Hybrid search combines both. Dense vectors for semantics plus BM25 for keywords. This is the best approach for production RAG. Use both and you get the best of both worlds. User queries are often vague. Query rewriting fixes that. Query decomposition breaks complex questions into smaller subqueries. Retrieve for each, then combine the answers. HYDE generates a hypothetical answer first, then it embeds that fake answer and searches with it. This aligns the query with document space. Step-back prompting asks a broader question first. It retrieves general context, then answers the specific question. Multi-query generates multiple variants of the question and retrieves for all of them. Reranking is the secret weapon. First, cast a wide net with retrieval. Get maybe 50 candidates, then use a cross-encoder to score each query document pair. Cross-encoders are more accurate than bi-encoders but slower. That's why you use them on a small candidate set. Reciprocal rank fusion is another approach. It merges ranked lists from different retrieval methods. The formula is simple. Score equals 1 divided by k plus rank. The production standard is hybrid retrieval plus cross-encoder re-ranking. You must measure 3 things. Faithfulness. Is the answer grounded in the retrieved context? This catches hallucinations. Relevance. Are the retrieved documents actually relevant to the question? Answer correctness. Is the final answer factually accurate? Use tools like RAGAS, Deep Eval, or TrueLens. Automate evaluation with LLM as judge and reference-based metrics. If you're not measuring, you're guessing. Building an eval pipeline has 4 steps. Step 1. Create a test dataset. Curate question-answer pairs with ground truth. Include edge cases. Step 2. Run your RAG pipeline on those test queries. Log the retrieved contexts and generated answers. Step 3. Score with metrics. Compute faithfulness, relevance, and correctness. Automate with RAGAS or deep eval. Step 4. Iterate and improve. Identify failure modes. Adjust chunking, retrieval, and prompts. Track improvements over time. The full pipeline has 5 stages. Query processing, parse, rewrite, and expand the user's question. Document retrieval, hybrid search plus reranking to find the top K documents. Context augmentation, inject the retrieved context into the LLM prompt. Answer generation, the LLM generates a grounded response from context. Validation, check faithfulness and flag hallucinations. Key insight, each stage is independently tunable. Start simple, measure, then optimize the weakest link. Every RAG system has 2 phases. Ingestion runs offline, load documents, chunk and pre-process text, generate embeddings, store in the vector database, and index with metadata. This runs once or periodically when documents update. The query phase runs online, receive the user question, rewrite and expand it, retrieve relevant chunks, build the augmented prompt, generate the answer, and validate it. This runs on every single user query. Keep ingestion thorough and query phase fast. 6 things to remember. 1. Chunking quality directly impacts retrieval accuracy. Get this right first. 2. Hybrid search outperforms pure vector or pure keyword search. Use both. 3. Query rewriting significantly boosts retrieval recall. 4. Cross-encoder re-ranking improves precision at low cost. 5. Always evaluate faithfulness, relevance, and correctness. 6. Start simple, measure everything, and optimize iteratively. That's RAG. From vector databases to full evaluation pipelines, head to dataforall.dev to practice everything we covered today. Every concept has hands-on exercises. Build a real RAG system step by step. Link in the description. If this was useful, hit subscribe. We've got the full generative AI track covering prompt engineering, agents, fine-tuning, and more. Happy learning and peace.